Good afternoon, everyone. I'm Bob Usher, Content Manager for LGfL, and the session's mainly going to be delivered by our jet-setting robotics expert, Rob, who, let's be kind this afternoon, he has got extreme jet lag, and he says he's trying not to fall asleep. I'm sure you'll be fine, Rob. Thanks for coming along and having interest in this pilot. We've done a few pilots at LGfL in the past. Immersive platform Sandbox AR, we did a pilot, and we also have done a pilot with Obot recently. And the focus of those pilots is about giving access to our schools within the LGfL community to new technology, but giving them the freedom, with support, but giving the freedom to explore this new technology to meet the needs of the learners in your context in schools. And that's the spirit within which we're going to be running this pilot. But I just want to be really, really clear about what we're looking for, because we are publicly making this as an open offer. If you're interested in being part of this pilot and this very robust technology that Rob was chucking around on the stage earlier this morning, and you like the sound, A, of this technology, and B, that you might be able to get it without having to pay for it, and that's why you're sat here this afternoon, I just want to be really, really clear. There's a QR code here that takes you to a portal that talks about the pilot. And I've tried to write the information on that portal to be really, really clear about a particular point. We are looking for real-world application of robotics, and I'm never going to come up with a better example than a Romanian sewerage cleaning robot that Rob showed. And I'm being serious, actually. It is a perfect example of we are looking for schools that want to explore real-world application of this technology. So it's not about making a robot dance or play games. We want to look at a real-world process. We've got one school that's interested that said they want to turn the robot into a roving autonomous vehicle that would go into disaster recovery zone after an earthquake, and that they would configure the sensors to be able to listen for survivors. That's another example of real-world application. It's that kind of thing. But the QR code takes you to a portal, and I've written some FAQs and some criteria to what we're looking for. We are very grateful to Rob and the team at Shape Robotics for their generous donation of this technology, but it's a limited amount. So there is criteria, and you do need to apply. And the other thing is, if you're on the portal, you'll see that it's quite a tight timeline on this. So the deadline is the 14th of July if you're interested in taking part. Rob, over to you.
So to help you with your decision making as well, I know you're interested in the solution, but what I want to do is to show you how it works. You know, it would have been great to have had all the robots for the project here. I was trying to get that, but it was having to be shipped and it just didn't arrive. Bob talked about the sewer activity. We actually presented that to the Romanian government, and they were there assessing our bid. You know, I don't know if you all know, but there's lots of European money around about the recovery and resilience in Europe. I think we left Europe at probably, I don't know if it's the right time or the wrong time, but there's millions and millions of euros being pumped into education in Europe at the moment. And we bid for a €400 million STEM lab concept. And we won the bid to put 1,000 labs in 1,000 schools. And they looked at our content, and we showed this real-world application, and they loved it. We actually got the minister driving a robot through a sewer that we made out of coriflute that you would find in your school, and cardboard that you'd find in your school, and they cleaned the pipe up. So it was really good. Interestingly enough, when you talked about the disaster robot, Class VR, which is one company we work with, have created a disaster zone that you can go in with the VR and explore all the different areas as well. So again, we're working with these other companies to give children the best possible set of resources to learn with in the real world as well. So what I want to show you today is how the system works. So you get an idea, you get a feel for it, and then you can ask any questions as well going on from there. So looking at the screen, so we've got a piece of software called Fable Blockly. So it is Blockly programming, but it also has Python as well. So it does fit obviously into primary, but it also goes into lower secondary as well. And with changes in the curriculum with computer science, we're now seeing AI and robotics being referenced in the computer science curriculum. I wish it said, get your hands on it, but it doesn't. But we're aiming here at the Key Stage 2, Key Stage 3 market. Can it go into Key Stage 1? Yes. Okay. You can come and have a go later, but pulling it apart is, you have to be strong. But if you use your elbows as a lever, it becomes a lot easier to pull the magnetic parts apart. So let's have a look how it works. As I said before, we have two products. We have a driving robot, like a rover, and we have a robot arm. Okay, so we have two products, and they come in these boxes here that you see. And there's only between 10 and 15 pieces in each box. So from a classroom management point of view, they're big pieces, they're easy to manage. Okay, so that's a real plus. So packing away takes literally less than 1 minute to put it all back in the box. So that's a really good point to point out. So how does it work? I've got the cable around my neck. So we have this special hub that communicates with our robots. Okay, now if you look at the software at the moment, it says hub not connected. All our electronics has an ID on the back. This is a 4-digit one called 132G. And all of our modules that are electronic have an ID as well. This one's called 61. Okay? And the reason for that is when I plug this in now, and I'll just plug this in for you, you'll see it should, if I've plugged it in right, it lights up, and on the screen there, it says 132G. I know I'm connected. Okay? Now, this is red. This is really important because the way we connect our robots is by colour. And there are 6 colours. So in Bluetooth, normally you have to search, yes? And you have to find the ID. You don't. You find the colour. Okay? So if I choose this as blue, and I pick up my robot arm, as an example, this is called 4HM. If I turn it on, it's red. Oh, no. And it says there, naught found, because we're not the right colour. And all I do is click through to blue, and in a second it now says 1 module found. That's it. That's how children connect their robots. That's ready for me to program. It's got its own little stand. I'll put that in there. And this particular one has got an X motor and a Y motor. They're servo motors that move one way and another. Okay, they're really robust. You can't break that. Okay, so children physically manhandling it, just like I threw it earlier, it won't make a difference. Okay, so I'm just going to put it down there like that. If you look at my software now, I can check if I click on the I for information. If I go too far away here at the moment, I'll come back again. The one thing we found, the only negative, I will be honest about negatives, Bet Show for us was a nightmare. If you think about all the Bluetooth devices in the Bet Show, when you've got thousands, then you have to bring your robot a bit closer to the hub. In your classroom, it doesn't matter. Okay, so if you take it too far away in here, then it might say, I can't be found. Okay, so what I'm going to do is just put it here for you. I'll put it there. There we go. That'll be fine. Okay, so how does it work? Well, I want something to happen. I'll click on Actions. And the other thing is we've got a simple mode and we've got an advanced mode. Okay, so I want something to happen. And this is called my robot arm. It's called our joint module because it's got 2 joints. And if I bring in the joint module, okay, it says move my joint module to angle 0, 0. So if you look at there and watch what happens, 0, 0 is that on my robot. Okay, so 0, 0 is standing upright. Okay, if I want this robot to now go, or this robot arm to go 90 degrees, the top motor, or 45 degrees, click on here, press play, it now turns 45 degrees. Okay, and all we do is to make a program, build a linear program, we drag blocks in. So I can drag another block in. And let's do something different, like a windscreen wiper. There we go. So I'll just put it to the front again, hit play, see what happens. It goes one way, and it goes the other way. So we can build up a program really quickly. Yeah, and it's as simple as that. If you notice also on the right-hand side, you can see Python being generated. Okay. What's nice about this is when I'm abroad, I describe it as subtitles when you're learning the English language. They're there to help you. But when you're ready, you can click into Python, and I can start editing in Python. So I can actually start typing in Python and running my programs in Python as well. Once you start editing in Python, because Python is very open-ended, and there are libraries in Python that are not in Blockly, you can't go back. That's just one note. Okay? Once you've changed things in Python, you can't go back to Blockly. But most children, and when we tested it, when do you change from Blockly to Python? Normally when you start doing lists and variables is normally the most efficient time to swap between the two languages. Before that, it's actually more efficient to stay in Blockly. When you start going into variables and start going into lists, that's when we move into Python. It becomes much more efficient when you're doing that. Okay. How long have I got, Bob? I haven't got long, have I? Okay. The same with this one. I'll show this one at the end, but we've obviously got our spin module. And what's really cool is when I turn this on, if I flick through to blue, you'll notice in here, fingers crossed, I told you there's Bluetooth going on in here. We'll give it time to think. That will be found in a moment. So I can actually build more. There you go. I can put multiple robots on one computer. So you could have, I've seen it done, 10 modules on here. Somebody built a spider that moved along, and then it had a head on top that turned and was looking around. You can do things like that. Or you could have 10 laptops controlling 10 individual modules. So the flexibility is there to be really creative. Yeah? The other big thing is the use of your mobile devices. So if you have iPads or Android tablets, phones, all phones, so whether that's Samsung, which I mentioned earlier, or iPhone, Nokia, Motorola, we have a free app in here that you can also connect to your robots. Okay? It looks very, what's the word? Very, very young app to begin with, but you'll see the power of it in a moment. So I'm just going to load it up. Again, you won't see it very well, but it's actually saying the only hub I can see in this room is the one connected to your laptop. And if I click on it and say connect, hopefully again with the Bluetooth in the room, that should change to 3 found in a moment, and I'll get control of my mobile phone as well. So it does depend on the Bluetooth. It's quite a lot in here today. So I can take control of my mobile device. I can do stuff with the eyes. So, why do we use, there's been a lot of research on social robots. Why do robots in department stores and stuff have eyes? Because there's so many people still quite nervous about robots. So you'll see that robots in retail do have eyes as well, or do have a face. So I can program this to do various things, to sort of communicate. I have actually seen a group in a maths lesson do a sine cos wave, which actually had the eye spinning. Reminded me of The Exorcist, if you've ever seen that movie, but you had the eye spinning. But the other really powerful thing about this is I can then take control of all of my sensors on my mobile phone and incorporate that into my programming. So GPS, I can, if you're in a good area, where you haven't got too much interference. I can send my robot to a point on the playground. I can use the touch screen. 2 fingers drives the robot forward, 3 fingers drives the robot backwards. I can use the accelerometer as well as a remote control. So you can take control of everything on here and use it, which is, I think, really, really nice feature. Now, the eye for information will tell me which robots are linked. And as I say, with this one, I think I've just got too many things going around in this room full of Bluetooth that it's not picking it up. But the mobile phone adds another light of using all of the sensors with the mobile phone in my programming, which is really nice as well. Okay. The other aspect as well is we've obviously got the VR aspect, but then we've got the 3D printing. You know, I started with my students getting them to program the ball to go around the maze, which is quite a nice one to introduce them to programming. We have groups of children that then design their own mazes. They take this off, and they can screw it onto this magnetic holder that then goes back on the robot. So you can design your own 3D elements and actually screw it onto here and use it within your robot design. So we had one group of children who wanted a drumming robot. They 3D printed 2 drumming sticks, and the robot played the drums. When I say the robot played the drums, is I had a drum there and a drum there. I can't find my other phone, so I use my one. And let's see if I can get this. This phone is it's one of the big maxi phones. There we go. So I actually had the phone connected, had the drummer drumming, and then they had the eyes looking down at what drum they were playing at any one time. And of course, you can get it to move as well. So this is 3 units connected together. So once the children have learned how to code, once they understand how this works, they come together in a bigger group and they build a bigger robot as well. Now, with the one that we talked about with the sewer robot, what they did, take this all off, and again, it's really quick to pull apart, is the robot drove down the sewer, and then they used the robot arm to clean the sewer. Okay, they designed a little plough in front to sweep the bottom part, and then the children designed a scraper for the robot arm to clean the top of the sewer. So they combined 2 robots together to come up with a really neat design as well. Now, one point, we will do training for the schools that become part of the project. Do you notice that changed colour? Yeah, I picked it up and I had it like this. So my only thing that children do that you just have, because what happens, they go, it doesn't work. And the first thing I say to them is the colour the same? And what I did is I picked it up like this and I had my finger on the button. It changed the colour. So that's the only thing you find with the children they do. And it's just remembering that's such a simple thing for them to check before they come and ask you. So I always teach them that first. Go on, ask questions. Yes. Yeah, so in each box, when you get your box, I think one of them's empty. So let's just have a look. I know, 5 minutes, yeah. That one's being used on display, so I'll take this one apart. So in your box, that's what the rover looks like, okay? And inside this is the hub. We actually did this like this because during COVID, what schools are doing in certain countries is they were buying just this, because obviously with the different colours, you can do programming, and they were sending this home with activities for the children to do so they could still have a practical hands-on coding session, but just with a £50 hub, not a £500 robot. Okay? You have to have the hub to do the programming, and the reason being is of the code behind the robots working. Yeah, and if you think about when you use Bluetooth, because it's a great question, when you use Bluetooth, you have to pair everything. This takes all the classroom management hassles out of pairing. Because if you just match the colours up, they'll link together and work. So from a classroom management point of view, this has been really successful, but you have to have it to run the robots. Yeah. But if I wanted to program 6 on my computer, I only need one hub. So it's one hub per computer, if that makes sense. So if I'm only giving one child one robot, there's the hub. But you might give them 2 robots to do a bigger project on one computer. See, but you only need one hub for that, if that makes sense, yeah? And then inside the base of your unit, you'll find all little bits. So with this floor robot, we've got a football, we've got some snow plows and extras just to, engage the children in other activities. But this is what the box looks like. Say again? Yeah. We don't do. We have a partner outside. They'll talk to you about pricing. I don't do sales. But basically, you buy either the spin module or the robot arm. Most schools buy a mixture of the two because the lessons on our website, you can have both lessons running with both products because I wrote them and I made sure that if you've got both products, you can do a lesson with, and follow the same content. Most schools buy both because you can then build the cool models to do the extras. Okay? We are delivering the robots. I think they're arriving in the country next week. So the robots are coming in. You've got a certain number coming in. So that's all guaranteed. And, Bob, if you just quickly want to talk about the...
Well, it's just to finish off, first of all, of course, to say thank you, Rob, for coming along and giving that really helpful demonstration. The second thing to say is, Rob, you are around after this. In the next session, he's available, and you can have a look and chat with the partners outside as well to get a bit more detail and ask all of those questions there. And then the third thing is just to reiterate what I said at the start, which is about real-world application. And I understand that, you ideally need to get your hands on the technology first before you can be really, really clear about how you want to apply it. However, we have a limited number of these units that are going to be made available for the pilot, and we need people to apply. Be imaginative. Be imaginative with what you see here and your aspiration for what you think you could do with your learners. And you know your learners. We don't. You know your learners in your school. You know the kinds of things that's going to capture their imagination and foster that creativity that was talked about this morning. So we're going to have to end it there. Thank you again, Rob.
Can I say one thing really quickly? Sorry. STEM, for example, just talking about STEM really quickly. In general, what bigger pieces allow you to do in a STEM lesson is have a really balanced lesson of design, test, redesign. Because what I found as a teacher myself using construction kits is you only ever get time to build it once because it takes so long to build. What you need to plan when you do your activities is there will be time for children to test their designs, evaluate their designs, and then make adjustments before they tell the whole world about what they've created. Okay, so that's one takeaway from that.
Excellent. Thanks again, Rob.
Yep.